Although there are numerous voltage systems, this video identifies and describes the 5 most common voltage systems. These 5 basic voltage systems supply the majority of residential, commercial, and industrial electrical services. The 5 most common voltage systems are shown here. Although there are other voltage systems than the ones shown here, these 5 systems are the most common. Please note that the numeric values that identify voltage systems may vary, but the values represent the same standard system. The source of electrical power is typically located a great distance from the point of consumption. To overcome transmission power losses due to distance, very high voltages are transmitted. These voltages can be well over 100,000 volts. To reduce this voltage to a safer voltage, transformers are used to reduce the voltage. The high voltage used in power transmission may be stepped down several times before reaching the point of consumption. The voltage is then consumed by homes, businesses, and industries. Let's examine these basic voltage values. An electrical term that may be included to identify an electrical system is the word phase. A phase refers to an AC sine wave. 3 AC sine waves are transmitted from the power source. A typical home uses only one of the 3 phases. Therefore, a house voltage may be identified as 120, 240 single phase. Most commercial and industrial electrical services use all 3 of the power phases and are identified as such. Please note the symbol for the word phase. This video identifies common voltage systems and typical voltage measurements. Please note that electrical codes apply to all voltage services and voltage systems. Refer to the National Electrical Code for rules and regulations pertaining to electrical services including grounded conductors, grounding conductors, bonding requirements, and equipment grounds. Code requirements are intended to create a safe electrical system. Before identifying electrical systems, it is important to understand the basics of a transformer. A basic transformer changes an incoming high voltage into a lower voltage. This type of transformer is called a step-down transformer. An incoming high voltage, called the primary voltage, is connected to the transformer. It then transforms the high voltage into a lower voltage, called the secondary voltage. The secondary side of a typical transformer consists of a single winding that is split in the middle. These 3 points are brought out of the transformer for external connections. The secondary voltage of the transformer is sent to the electrical service. Most residential services and some commercial services are supplied with a 120, 240 volt service. The service is supplied by a transformer. The power is then metered and supplies a breaker panel. Inside of the breaker panel, the feeder wires from the meter are fed to a main breaker. The main breaker supplies power to the branch circuit breakers. The power to the panel consists of a white, neutral conductor and 2 hot conductors. These may be called line 1 and line 2. The voltage from the white neutral conductor in line 1 is 120 volts. The voltage from the white neutral conductor in line 2 is also 120 volts. The voltage from line 1 to line 2 is 240 volts. The main breaker supplies power to all of the branch circuit breakers. A 120 voltage branch circuit is supplied by a single pole breaker while a 220 volt branch circuit is supplied by a 2-pole breaker. Devices such as dryers, air conditioners, water heaters, and ovens require 240 volts. Circuits other than appliances require 120 volts. As stated before, transformers are used to step down a high voltage to a safer, lower voltage. While a single-phase voltage system uses only 1 transformer, 3-phase systems use 3 transformers. Each of the 3 transformers consists of a primary winding and a secondary winding. The primary winding is designed to accept the incoming high voltage, while the secondary winding is designed to produce a lower voltage. The 3-phase voltage delivered by the transformers is determined by the secondary winding connections. Let's examine the different transformer connections and the voltages that are produced. The first 3-phase voltage system that we'll examine is a 120, 240 volt 3-phase system. This is referred to as a delta connection. A delta symbol is a triangle. The secondary connections of the three transformers are connected in such a way as to schematically form a triangle, or a delta connection. Notice in the drawing, the red, blue, and orange connections are used to complete the delta connection. Notice also the white neutral conductor comes from the center tap connection of one transformer. The black, three-phase power lines to the service comes from each corner of the delta configuration. The 120, 240 volt three-phase power is sent to the electrical service. First the power is metered and then sent to the main service disconnect. Let's identify the phase-to-phase voltages and the phase-to-neutral voltages. The three power legs of the service are identified as line 1, line 2 and line 3. Identified here as L1, L2 and L3. The neutral connection is identified with the letter N. First, let's look at the phase-to-phase voltages. The measured voltage between any two power connections is 240 volts. The voltage from L1 to L2 is 240 volts. The voltage from L1 to L3 is 240 volts. And the voltage from L2 to L3 is also 240 volts. Next, let's look at the line to neutral voltages. The voltage from L1 to the neutral conductor is 120 volts. The voltage from L3 to the neutral conductor is also 120 volts. It is very important to know that the voltage from L2 to the neutral conductor is not 120 volts. This voltage is about 208 volts. This higher voltage is sometimes called a high leg. Identification of the high leg is required to be identified with an orange marking. It is very important so that 120 volt devices are not connected to it. Although three-phase breaker panels are available, a common wiring practice is to connect a single-phase breaker panel to line 1 and line 3. This eliminates the possibility of accidental electrical connections to the high leg. No matter the wiring situation, attention must be given to the high leg. The next three-phase voltage system that we'll examine is a 120, 208 volt, three-phase system. This is referred to as a Y connection. The secondary connections of the three transformers are connected in such a way as to form the letter Y. Notice the connections in the drawing that one side of each transformer is connected to form the inner part of the Y connection. This is the neutral connection point. The three power legs of a Y systems come from the opposite side of the neutral of each transformer. The four conductors, the neutral, line 1, line 2, and line 3, are sent to the electrical service. From the transformers, the power is sent to the electrical service. The power is then metered and typically sent to a main service disconnect. The main service disconnect then distributes the power to other disconnects and breaker panels. Let's examine the voltages of a 120, 208 voltage system. The three power legs of the service are identified as line 1, line 2 and line 3. Identified here as L1, L2 and L3. The neutral connection is identified with the letter N. First, let's look at the phase-to-phase voltages. The measured voltage between any two power connections is 208 volts. The voltage from L1 to L2 is 208 volts. The voltage from L1 to L3 is 208 volts. And the voltage from L2 to L3 is also 208 volts. Next, let's look at the line to neutral voltages. The voltage from L1 to the neutral conductor is 120 volts. The voltage from L3 to the neutral conductor is also 120 volts. The voltage from L2 to the neutral is also 120 volts. Notice that in this voltage system that there is no high leg. Any single line voltage to the neutral is 120 volts. This system is sometimes preferable when there is a large lighting load demand. Since this system does not produce a high leg, a common wiring practice is to use a three-phase breaker panel. A three-phase panel allows for supplying power to not only three-phase loads, such as motors, but also single-phase loads such as receptacles. Although commercial and industrial electrical services can be supplied by either a 120, 240 volt service or a 120, 208 volt service, commercial and industrial buildings can be supplied with a 460 volt service. 460 volt services are typically best suited to supply a premise with a high load demand for motors and lighting. Let's examine 460 volt systems. The transformers used on a 460 volt system produce 460 volts on the secondary winding. The first system we will look at is identified as a 277, 460 volt three-phase system. As with a 208 volt system, the transformers are configured in a Y connection to supply a 277, 460 volt three-phase system. Notice that one side of each transformer has a common connection point, which is the neutral. The opposite side of the neutral connection point supplies the three power lines. Line 1, Line 2, and Line 3 are sent to the electrical service. The 277, 460 volt three-phase system is supplied to the electrical service. It is metered and sent to a main disconnect. Let's examine the voltages of a 277, 460 volt, three-phase system. Each phase-to-phase voltage of this system is 460 volts. The voltage from line 1 to line 2 is 460 volts. The voltage from line 1 to line 3 is 460 volts. The voltage from line 2 to line 3 is 460 volts. Each phase to neutral voltage of this system is 277 volts. The voltage from the neutral to line 1 is 277 volts. The voltage from the neutral to line 3 is 277 volts. The voltage from the neutral to line 2 is 277 volts. Let's examine how the 277, 460 volt system is typically distributed in an industrial premise. The voltage is distributed to all of the industrial motors. Each motor is required to have its own disconnect means and overload protection. Many commercial and industrial premises have large lighting loads. There are advantages in using 277 volt lighting. To supply this voltage, a 277 460 volt panel is installed to distribute 277 volt power to the building lighting load. Since a 277, 460 volt system does not supply 120 volts, a transformer is required to step down the high voltage to supply 120 volt loads. A typical system uses a floor transformer. A typical floor transformer converts three-phase, 460 volts to a 120, 208 volt three-phase system. The output of the transformer is connected to a breaker panel which distributes the lower voltage. This system is common in many commercial and industrial buildings. One uncommon voltage system is a 460 volt grounded corner. Although this system is uncommon, it is important to know the voltage values of this system. This system is typically used for systems with one large motor or systems with a very large motor demand. The transformer secondary windings are arranged in a delta configuration with one of the corners grounded. The grounded corner power line and the other two power lines are sent to the electrical service. At the service, the power is metered and sent to a main disconnect. Please note that the electrical code provides special rules and regulations for this system. This includes grounding specifications and overcurrent devices. The 460 volt grounded corner system does not have a neutral connection. Therefore, all of the phase-to-phase voltages are 460 volts. The voltage from L1 to L2 is 460 volts. The voltage from L1 to L3 is 460 volts. The voltage from L2 to L3 is 460 volts. Refer to the National Electrical Code for proper wiring techniques of this system. There are typically several factors that determine the voltage system for a premise. Homes and small businesses typically have a 120, 240 volt single-phase service. Larger commercial and industrial businesses typically have a three-phase service. Typically the voltage is determined by the percentages of motor and lighting load on the premise. Whatever voltage is delivered to the building, it is important to know these values. The 5 voltage systems reviewed in this video are the most common. It is also important to know that all premise wiring, including the service, and all interior wiring should follow the requirements found in the National Electrical Code.